Place at the desk, Tomaž Zore, who developed a system called Bufoil, and he showed us his boat flying on the water, and now we can go deeper in discussing. Please.
Hello, my name is Tomaž Zore, and today I'm here to present my work in the field of hydrofoils. I'm the founder and the leader of the TWF project, which has been running for the last 30 years. I have developed some kind of new hydrofoil concept and named the TWF concept. So my starting point was my aeronautical and aerodynamic knowledge and a lot of experience as a pilot. I have more than 12,000 hours on different types of aircraft. As I have seen, I'm the only one at this event presenting a hydrofoil powerboat concept. At this point, I have to say that the TWF concept is a hydrofoil concept which is suitable for powerboats and for sailing boats as well. We started with powerboats because powerboats represent approximately 80% of the leisure boat market, and of course we would like to live of our work. But my soul and passion go to sailing, definitely. And maybe someday I will get a chance to apply the TWF concept to top sailing boats as well. So my brief presentation today will explain the basic characteristic of the TWF concept, its advantages and its potential of applying to different vessels. Let's start with the basics. As we all know, we have constant wetted systems with a high regulation, and we have hydrofoil concept, which is a combination of constant wetted systems and surface piercing systems. But with our TWF concept, we are thinking a little bit differently. So the TWF concept is a surface piercing 2V canard hydrofoil concept with a swept hydrofoil design which enables cavitation control. That's the definition in general. So the essence of transonic aeronautics is to control local velocities and pressures on the wing. I am using the same tricks and solutions as passenger and military jets. Behavior of the water at the speed of 40 knots or more, that of course depends on the hydrofoil cross-section on hydrofoils, is very similar to behavior of the air at the wing at around Mach 1. First, I would like to explain a few basic things in a very popular and simple way. Let's look at the similarities between the water and the air. We have the same number of balls passing over the certain surface per time unit in the water and in the air. The difference is that on one side we have high density in the water, and on the other we have high speed in the air. Imagine that balls passing over the hydrofoil are connected with the elastic rings. With the pressure dropping, those rings become more and more strained. The balls, if we look three-dimensional, the balls spatially spread out. And at a certain point, that links just break. We call at that point cavitation appearance or boiling of the water. The local speed on the upper surface of the hydrofoil is the controlling element to not reach the point where cavitation appears, or according to my popular explanation, where the elastic rings between the balls break. That was some basics. Now I would like to present advantages of the WFOIL concept and compare its characteristic with the classical T or L settings of hydrofoils. With the WFOIL concept, the wetted surfaces of all hydrodynamic elements are reduced with the speed increment. So the main hydrodynamic drag stay at the same value throughout the whole speed range. Here I would like to point out that here I'm talking just about the main hydrodynamic, the profile drag. Here we can see that the constant weight, here we have an example for just one foil. Constant weight means the constant lift. So the product of this formula has to be the same. This is the formula for the lift, as you know, and the same story is with the formula for the drag. So with speed increment, square of the speed, the wetted surfaces have to be reduced. The WFOIL concept produces approximately 30% more drag than the constant wetted concept at the moment when vessel becomes foil-borne. But its water drag stay, I'm talking just about the medium water drag, stay at the same value throughout the whole speed range, while the constant wetted concept gain we saw from the formula, its water drag with the square of the speed. As a benefit of the WFOIL concept, there is a possibility of changing the beta angle. So, at low speed, we can operate very close to TL concept, this position of the hydrofoil, and with speed increasing, we can increase beta angle and gain all the benefits of the WFOIL concept. The 2V surface piercing hydrofoil setting is a perfect platform to explore the swept hydrofoil design to its maximum and to control cavitation appearance up to speeds greater than maximum speeds reached by hydrofoil so far. There is a great difference of the progressive speed of the vessel and the local speed of the water on the surface of swept hydrofoil. The local speed is responsible for lift, drag, and cavitation appearance. And just short definition, the local speed is always a component, as we see from this diagram, of the progressive speed of the vessel perpendicular to the tangent on the leading edge of the hydrofoil. Because of applying the swept angle to hydrofoils, we can reach much higher maximum speeds with the WFOIL concept than with other hydrofoil concepts. For example, maximum, now we're talking about the design speed of our albatross is around 60 knots, and the concept theoretically can go up to 80 knots, maybe more, in general. Additionally, of course, we can control cavitation appearance with the hydrofoil cross-section optimization. With our hydrofoil design, we have reduced induced drag as well. At the tip of the hydrofoil, the swept angle is 90 degrees, and consequently, the lift of the hydrofoil there is very close to zero. Because of the curved swept leading edge of the hydrofoil, we can control the appearance of cavitation. At the tip lower area, the hydrofoil is designed with a great swept angle and it's suitable for high speeds, while at the upper root area, the hydrofoil is designed with a small or zero swept angle and it's suitable for low speeds. So, when at high speeds, the waves flow over tip area and reach upper root area, which is not designed for high speeds, cavitation appears and reduce extra drag and lift. That makes the flight much smoother than it would be without such a hydrofoil design. Here we have another advantage of the WFOIL concept. The WFOIL is an arc-of-the-beam concept. Because of that, we can load greater load, or we can reduce hydrofoil load for greater speeds. We can lift hull out of the water at lower speeds. With the WFOIL concept allow us to design hydrofoils with the big root section areas. And that allows us to lift hull up to the water at really low speeds. You can, it was yesterday on the water, you could see that when I pulled the throttle, the boats went out and it's immediately. Theoretically, the minimum foil-borne speed for our albatross is approximately 5 knots. That depends on the weight, 1 or 2 passengers. Now let me explain briefly the stability of the WFOIL concept. Here I would like to point out that I'm using I come from aviation field and I'm using the aviation phraseology. I would like to excuse because of that, but that's bank stability you call it here or something. Yeah, I learned now. Now let's start with the bank stability. The 2 times really handler allow us to reach great stability around the longitudinal axis, and that's this. I have to point out that we are achieving that just by settings and shape of hydrofoils without any movable control surfaces. The only movable control surface is rudder in our boat. Pitch stability of the WFOIL vessel can be already compared with the pitch stability of the classical boat hull. In the case that front hydrofoils are wetted more than necessary for certain speeds, they produce extra lift and raise the nose of the vessel. That was for the long race. For short waves, the hydrofoil just cuts the short waves because of the inertia of the vessel. And with a speed of more than 40 knots, the phenomenon of supercavitation bubbles on hydrofoils starts to prevent pitch oscillating caused by the waves. And finally, yaw stability is achieved by 4 foils themselves. Additionally, we can stabilize the vessel with the rudder, and the rudder allows us to compensate for possible momentum produced by the sails. Power version could be equipped with backward thrust, which brings completely different dimension in yaw stability and maneuverability. I borrowed this diagram from Mr. Spear. It is one of the best and most user-friendly diagrams for such a case. Thank you, Mr. Spear. If we analyze this diagram, we can see that the WFOIL concept improves all, here I mentioned just 3 elements. We are increasing load factor with the canard concept, the speeds or local speeds, in our case, with the swept angle on the hydrofoils and the lift coefficient. With the canard concept as well, and that's because of the lower hydrofoil loads. Here you can see one of the possible application of the WFOIL concept. With the crossbeams designed as a real aircraft wing with aerodynamic control surfaces, we can easily design a hydrofoil vessel and hydroplane in one body. Such a boat plane could operate in low waters as a boat or as a hydroplane, which is capable of takeoff and landing in the low seas as well. The WFOIL 18 Albatross is our prototype concept boat. It was built just as a proof of concept and shows the direction of future WFOIL boats and maybe hydroplanes development. As a base, we choose the concept of boats from Polynesia, a concept which is reliable and efficient in all weather conditions, a concept which was developed and proved through the centuries. We also know that the boats of the future have to be really energy efficient and supportive to their users. We make boats fly and we make green-oriented boats with very low CO2 footprint as well. So after extensive testing program and a lot of public presentation, we carefully analyze our feedback and completely redesign our Albatross. We got technically improved and the most important, market acceptable hydrofoil water jet vessel. Its name is the TWF Jet, and the prototype is already under construction. The TWF concept has never been proved as a sailing boat, but during our research period, we made a lot of testing with the radio control models, filled with all possible electronics and with all possible directions and heights of the propulsion force. We found that the TWF platform is suitable for sailing boats as well. As an extra proof, we put an air propulsion or aviation power pack on our Albatros to show TWF platform's ability to support great pitch down momentum. So now I would like to present something for your brainstorming. Here I'm just theoretically comparing the TWF concept sailing boat with the AC-72. Please focus on the available force which is showing into the wind. So, the TWF concept produced the same amount of force in the vertical direction and in direction against the wind. And that is, of course, with a beta angle of 45 degrees. But we can constantly change this beta angle, and with that we can make constant adaptation for sailing conditions. Additionally, we can take hydrophiles completely out of the water for sailing with very weak winds or in very shallow waters. At the end, I would like to say thank you to all who make America's Cup campaign so recognizable. After the final regatta, everybody knows what hydrofoiling is, and a project like ours or yours, the people see project like ours or yours with a completely different perspective. It was noted. So in the week movie, the worst. Okay. Do you have a speaker? Or you can just put the microphone there. No, just switch off.
Controlli tu il volume.
Yes, can I start?
Try.
Do you hear? Powerful.
It's a marriage of state-of-the-art technologies and materials with old-school craftsmanship. We've perfected every detail to deliver a true piece of art made of carefully selected materials and cutting-edge technologies.
This movie was made because we are searching for investor, and it's not, I just put it in this presentation. Regarding my presentation, I know it was very brief, but for additional questions, I'm here in the available. I would like to say thank you to the organizers for giving me such a great opportunity to present my work. Thank you. Grazie.
Thank you very much, Tomaž. I think that you introduced a lot of questions, and I mentioned that during the discussion with Tom, there are several topics to discuss. I appreciate very much the study, the possibility to spread all the research in foil and solution, and the possibility to spread it in several kind of applications, not only competition, but draw from there some idea and make them more useful. So I think that could be a way that you suggest.
Just additional sentence from my side. I'm playing open game because the open code, like Google did, it's the only way to move this forward. I mean, in general, the high performance in general. And that's why I'm open for all questions at the roundtable or wherever.
Okay, we have time at the end of the morning. Please, I invite Giorgio to give us his conclusion of today.